number, that becomes an ironclad contract that you've bet your life you will finish that thing by that time. Another anti-pattern is the net negative producing programmer. And this is the really non-intuitive thing, that taking a poor performer off the team can often be more productive than adding a good one. Because writing code is different. And I think software development productivity would skyrocket if the least effective 30% of developers were fired tomorrow. Because writing software is not like digging a ditch. Because if you're digging a ditch, no matter how bad a ditch digger you are, you end up with more ditch. It may not be even or the right depth or whatever, but it's still workable as a ditch. The problem in software is the thing you build today is the foundation for the thing you build tomorrow. And having a really poor programmer in your team is chipping away at the foundation as you're trying to build stuff. And so taking a really bad developer off the team is sometimes much more useful than adding a good one to the team. And that's my second little strand that I'm pulling together. I've noticed a couple of new anti-patterns in my consulting career. One of them is a pattern I call frozen caveman. The frozen caveman pattern is where you have some person on your team that got really burned by something about 5 years ago, like scalability or multi-threaded access or something like that, and now that's all this guy thinks about on new projects. You can't get him to get away from that. It's like he was flash frozen at the instant he had that problem before and thawed yesterday and added to your project. And that's number 3. The next anti-pattern that I've noticed is one that I call the Rubik's Cubicle anti-pattern. Developers really like solving puzzles. And unfortunately, a lot of business applications aren't all that difficult. And so what a lot of developers do is figure out ways to make it challenging so that they're not bored anymore. And there are whole groups of 3-letter acronyms devoted to this, let's try to make it not boring anymore, like EAI and SOA and ESB are all ways that, this application's boring, but if we add all this stuff to it, it'll become exciting. I knew a project manager that kept on his desk a little jar of these toys that are made of nails that are really hard to get apart. You have to really think about getting them apart. And anytime there was a developer in the room and he wanted to have a conversation that he didn't want them to pay attention to, he'd pick one of those up and kind of toss it to the developer. And the developer would catch it and then develop this tunnel vision and start playing with it and just blanked out the entire world. And then 10 minutes later, he'd pull it apart and go, were you guys talking about anything important? It's like, no, it's okay. Don't worry about it. Those developers love to solve puzzles. All of these anti-patterns are part of the lore of software. Anytime that you have a manager tell you or try to pull this as now anti-pattern, you don't have to tell him, no, it won't work because I don't think it'll work. You've got this whole lore behind you of saying, look, people have been trying to do this for 30 years and it still won't work. So my next philosopher is Occam, Sir William of Occam, and Occam's razor, which is basically, given a number of solutions, the simplest one is correct, which can be further simplified into the KISS principle. Keep it simple, stupid. One of the things that Occam was really talking about here is complexity. This is one of our biggest problems today, is complexity. But remember Aristotle? And this whole business about essential and accidental properties, if you combine Aristotle with Occam, you end up with something I see a lot in software today, is this distinction between essential and accidental complexity. Essential complexity is we have a hard problem solve of some kind. Things have an inherent complexity in them that is part of the problem that you have to work on to solve. And this is a good thing, because this is what we have to attack when we write software. The problem is, we also have a lot of accidental complexity, which is all the innovative ways we've made the problem really hard. Because of legacy or whatever is going on in your project, there's a lot of accidental complexity there. And let me give you a couple of examples of this. This is Dave Thomas. He's a well-known author and speaker. He's one of the co-authors of Pragmatic Programmer. And he used to run a consulting business. And he was brought into this large insurance financial services company because they had a problem. They had a problem because they had so many internal memos that went through their office that they couldn't keep up. So their workers that were trying to sort all these things were just swamped all the time. And they were constantly getting misfiled letters because there was so much volume of traffic going through. And it was always tough because it got delivered to the wrong department, which means you had to go back to the mail room and get resorted. And so there was some delays. And so they thought, okay, the solution to this problem is technology. And so what they wanted to do is build this optical character reader that would automatically read the address on the envelopes and automatically sort them into their own special place. And when they envisioned this, they envisioned the sparkling floor where everything just kind of magically worked. And they actually bought readers and they started building all this stuff. And they brought Dave in as a consultant on this project. And he was listing the requirements for the first week or so. And, they got to the end of the requirements and he said, I'm sure you guys have probably thought of this, but couldn't you solve this problem by keeping your existing workforce and just switching to colored envelopes, one color per department? And they looked around stunned because that was the solution to the problem. They didn't have to build $2 million worth of equipment and all this other crazy stuff. They went to the office supply store and bought envelopes. That was the talent that Dave had for seeing through the accidental complexity to the essential problem and fixing it. In my own consulting career, I had this experience for a company, I'm sure you have them here, that when you buy a new car, when it comes time for your oil change, you get a little postcard in the mail that says, it's time for your oil change. And I worked for a company, this guy who had owned car dealerships, and when he owned car dealerships, he actually wrote some software to print these little things for his customers. And one of his competitors came to him and said, hey, that's a good idea, but I don't have to write all the software and all that, so can I just hire you to send them out for my dealership? Well, if you fast forward 10 years, that's his whole business. He's out of the car dealership business now, and he's just sending out those little reminders to people for auto dealers all over the country. There was only one problem. The only computer around to write that software was a Wang computer. So he wrote the whole thing in Wang Basic. He wasn't an experienced programmer. He was just kind of doing it by the seat of his pants, and he was kind of letting it grow over time. And of course, he has a whole business built around this thing now. But the problem is, by this time, Wang is out of business. And so he's literally shopping on eBay, looking for Wang computers that people are selling to get spare parts so that when his Wang pieces died, he could replace them. And he was getting older and he was having poor health, and his son had taken over the company, and they started over and over to rewrite this thing. But they suffered from what Fred Brooks called the second system syndrome. The second version of any piece of software is by far the most dangerous because all you can think about are the possibilities. And you get stuck in analysis paralysis. And they literally were in analysis paralysis on this problem until the last Wang hard drive died, and they put a padlock on the front door. They put off this problem so long that it ended up killing the company. It was just a giant mail merge. It was not a complicated problem, but they built it up into so much accidental complexity that eventually they had to put a lock on the door and just close the business down. Another way of saying accidental complexity is ceremony. And another way of saying essential is essence. So these two terms, ceremony and accidental complexity, are really related to one another. And that is the fourth thread that I'm pulling together. That was all prelude. Now let's talk about some recent history. Now, I have to warn you, if you react to this next slide, it will date you. Anybody here remember this? Anybody here old enough to remember this? Sidekick. This was the coolest thing ever back in DOS. Because in the DOS world, you could only run one program at a time. And when DOS 3 came out, Microsoft snuck in some code that would let you do background printing, because that was a big request. We want to do background printing. And so they snuck in some code into DOS to let you do that. People reverse engineered that, and these were some of the first guys to do it. While you were working away in your word processor or whatever, Lotus 123 on your PC, you could hit a hotkey and Sidekick would pop up. And you could do calendaring and Notepad and all that stuff, and then hit the hotkey again and you're right back in your spreadsheet. You didn't have to exit the spreadsheet and load another thing and